Hi students, in this video I'll be going through exercise 10E question 4. Alright, so let's read the question. So we are told that if P is equals to 1 plus cosine x over sine x, prove that 1 over P will be equals to 1 minus cosine x over sine x. Alright, so this is actually a trigo identity proving question, but they ask it in a different way. Alright, so P is 1 plus cosine x over sine x. So they want us to prove 1 over P is this, right? 1 minus cosine x over sine x. Okay, so we will start by doing this. Okay, so 1 over P. Okay, so P is 1 plus cosine x over sine x. So we will get 1 over 1 plus cosine x over sine x. Alright, so we get this. Okay, then from here we will just, if you do the manipulation, you end up with this. Sine x over 1 plus cosine x. Right, so if you are not sure about how this came about, it's just like if I have 1 over 1 divided by a over b, right? Okay, it's actually, you can actually write it in this form, 1 divided by a over b. Okay, it's the same meaning. Okay, so when we want to combine them together, we will flip, right? If we change the times, we will flip the fraction on the right, then we end up with b over a. Right, so in this case, now this top numerator is a, this is b. So when we do the division, it becomes b over a. Right, so this is the reason why it becomes sine x over 1 plus sine x. Okay, so at this point in time, you need to ask yourself, what else could be done? Okay, it seems actually like there's nothing much that we could do because sine x you can't change to anything. 1 plus cosine x also you can't change it to anything because there's no square. If there's a square, then maybe you can introduce some identity, right? Okay, so one way to solve this kind of question is this. We always want to try to be able to use the identity, but to use the identity, we will need a square, right? Okay, so what we can do is that we can multiply by this. Okay, this is something like rationalizing steps like that. We can sort of like multiply by the conjugate of 1 plus cosine x. So we will multiply by 1 minus cosine x. Okay, so you got to understand and know how to use this technique and when to use it. All right. Okay, but later on in the steps, you will see that what's the reason why we want to do this. Okay, so at the top, we will just have sine x times 1 minus cosine x. Okay, then at the bottom, okay, if you realize this one is actually of the form, right, a plus b times a minus b. Okay, then we end up with a square minus b square. So in this case now, a is 1 and then b will be cosine x. Okay, so we end up with 1 square, which is just 1 minus cosine square x. And over here, you can see the reason why we want to multiply by the conjugate of 1 plus cosine, because when we multiply by the conjugate, right, we will get 1 minus cosine square x. And this will actually allow us to use an identity. Okay, the identity will be sine square x plus cosine square x equals to 1. So if I shift the cosine square x over the other side, I will get this. Okay, and I can now replace the whole denominator, right, with sine square x. And this sine square x will actually be able to simplify with the sine x on top. Okay, so one of the sine x cancels with one of the sine x below, so you are just left with what actually they want us to show, which is 1 minus cosine x equals to sine x. Okay, so we have proven this. Okay, so do remember this method lah. Okay, it's actually a very useful method, multiplying by the conjugate. And why do I multiply by the conjugate? Because we want to have this square here, so that we can then later on use the identity. All right. Okay, the next part of the question is also rather interesting. They want us to find sine x and cosine x in terms of p. All right, that means they want us to just find sine x, and then on the right side, some terms, but everything must be in terms of p or some constant number lah. All right, so what do we have so far? So far we have p is equals to 1 plus cosine x over sine x. Okay, then 1 over p is 1 minus cosine x over sine x. Okay, if I want to find sine x only in terms of p, right, I need to somehow get rid of cosine in the expression. But over here you can see P equals to 1 plus cosine x over sine x. So both cosine x and sine x are existent inside the equation, right? Okay, exist inside the expression. Okay, but now I need just one of them by itself. Okay, so how can I get one of them by itself? Okay, you look over here. What these two expressions are rather similar. Okay, except that one is a minus, then the other one is plus. Okay, one is a minus cosine x, the other one is a plus cosine x. So if I want to get rid of the cosine x, I can do something like elimination method for simultaneous equation. I can add the two together. So that's precisely what we can do over here. So we can add p plus 1 over p. Okay, so p is this. Okay, then 1 over p is this, right? Okay, right, so we can now add them together since they have the same denominator. Okay, so we can add them together easily. We'll get 1 plus cosine x plus 1 minus cosine x. And you can see cosine x will now be gone. So we will have 2 over sine x, right? Okay, then at the same time over here, we can combine the p plus 1 over p together. And we'll get p squared plus 1 over p. Okay. So on the left hand side, we can also combine them together. So now all we need to do is cross multiply, actually just bring the sine x up. Okay, so we get p squared plus 1 times sine x equals to 2p. And then we'll divide the p squared plus 1 down, and then we will be able to find sine x in terms of p already. Okay, so now sine x is equals to 2p over p squared plus 1, right? So this will be the answer for sine x, right? Okay, so now I'm going to now we need to find cosine x. Okay, so now that we have found, sine x, right, in terms of p, we can actually just substitute it inside here, and then we make cosine x the subject, and then we will be able to get answer for cosine x already, right? So let's call this equation 1. Okay, so this one, let's call it equation 1. Okay, so p equals to 1 plus cosine x over sine x, we call equation 1. This one we call equation 2. And let's sub 2 into 1, and we'll be able to get the answer. Okay, so substitute 2 into 1. Okay, so if we do that, we will get p equals to 1 plus cosine x over, okay, sine x is 2p over p squared plus 1. Right, so this is what we will get. Okay. Okay, so now after we have substituted it already, okay, I'm just going to okay, this one, if you do the division, you actually get 1 plus cosine x. Okay, let me do the whole step out now. Okay. Okay, so 1 plus cosine x over 2p divided by 2p over p squared plus 1 is, okay, we can rewrite as this form, right? Okay, then all we need to do is now flip it. So we will get 1 plus cosine x times, okay, change the times, you will flip the fraction, right? This, right? So in the end, we'll get p equals to 1 plus cosine x times p squared plus 1 over 2p. Right, so now we will cross multiply the 2p to the left. So we get 2p squared equals to 1 plus cosine x then times p squared plus 1. Okay, then we'll divide the p squared plus 1, okay, below. So we'll get this. Okay, then we just bring the 1 over to the other side. Okay, so we write the cosine on the left side. So we get 2p squared over p squared plus 1 minus 1. Okay, then I guess we'll combine that with a single fraction. So minus p squared plus 1 over p squared plus 1. Right? So if you simplify the top, you'll get p squared minus 1 over p squared plus 1. Right? So this will be the solution for this question. Okay, so this is a rather unusual question. Okay, but I think the key thing here is the part 1. Remember, you can always introduce an identity if we have a square term, okay, so like cosine square or sine square. So how do we get the square term? We will actually just multiply by the conjugate, all right, in order to get the square term. Right, so maybe take some time, look through this video, because this question is quite different from the rest. Okay, but actually it's also not too difficult. Right?